All right, so a short lesson today, 2.6 similar figures. We're really just going to cover the highlights from this lesson, okay? You guys paying attention? Okay. All right, we're really just going to cover some of the highlights from this lesson. We're not doing all of the examples, so it's not going to match up entirely with your book, but what we believe is really important to kind of pull out a few concepts, and then we'll work on some classwork. All right, so the first thing you need to know about similar figures is what they are, okay? They're the same shape, but they're not the same size. So oftentimes you will see that a dilation is part of the transformation, if you will, from one figure to a similar figure. You would see that a dilation is involved, okay? And two figures are similar when one can be obtained by another, from another by a similarity transformation. And we know that those could be any of the transformations: rotation, reflection, translation, and we could potentially see all of those things. Okay, so let's look at the first pair of similar figures, okay? Now, from all that we know right now, just by looking at the figures, can we tell that they're the same shape? Can we tell they're the same shape? Yeah, we can tell they're the same shape. But clearly they're not the same size, all right? So we're on the right track, but we do not have proof that the figures are similar, okay? So walking around in some of my earlier classes today, I see them writing like for number 6 and 7, yes, they're similar because they're the same shape but not the same size. But they gave me no proof. So just visually seeing, yeah, they're the same shape but not the same size does not mean that they're similar, okay? We need proof, and the proof is in the ordered pairs. But you must choose corresponding ordered pairs, okay? So in order for these figures to be similar, because one is smaller and the other one is larger, there has to be a dilation scale factor involved. Remember how yesterday we dilated figures by a scale factor? You guys remember that from yesterday? Okay, so if these figures are similar, I should be able to pull out two corresponding ordered pairs and see a pattern. All right, so let's just point out two of them. Okay, doesn't matter which one, but do you agree that these points are on the same location on the figures? Do you agree that they're at the same location? So now let's write down those ordered pairs. What's the ordered pair for the smaller figure? What's the ordered pair that matches? 3, 3. What's the ordered pair that matches on the bigger figure? What is it? 6, 6. Okay? Now, you need to be able to look at these ordered pairs now and figure out if you see a pattern from the smaller x value to the larger x value, but it has to be the same pattern for the y values also. Now, in this one, it's a little deceiving because they're the exact same numbers, okay? But the y value has to be increased by the same scale factor, okay? And we are not adding and subtracting. So yesterday I struggled a little bit with that with some students. We're not adding and subtracting. We are multiplying or dividing, all right? So how would I get from a 3 to a 6? Multiply by 2. So I would say that a dilation is occurring here with a scale factor of 2. Okay? This is my proof, guys. I can't just say yes or no. Okay? Yes or no doesn't cut it. All right? I have to have proof, and my proof is in picking out two corresponding ordered pairs and looking for a pattern. All right, you have 2 of these on your homework tonight. Any questions? You have 2 of these on your homework tonight. Okay, any questions? And guys, if you had picked any of the other ordered points, you don't have to worry about, oh, did I pick, the right pair of ordered pairs? Any of the other corresponding points. So you could have picked the bottom one, or you could have picked the left point. It's still going to show you the same thing. Okay, so pick any pair, one of the pairs of the corresponding points. All right, now, okay, we're not doing that one yet. This one. Okay, sometimes the transformation is not a dilation. Okay, and sometimes figures can actually be completely congruent, but they're also similar. So that's something that we want to look at also. Okay, but again, I can't just look at this and say, oh yeah, they're similar because they look similar. Okay, I have to prove it. All right, and I prove it by picking corresponding points in the two figures. One y'all are looking at? Yes. Okay, and the corresponding point, oh goodness, do I need to reflect this first? I think it'll be okay. All right, so we're going to pick the points in the same location on the figure. All right, one we have at -3, 1, and one we have at 3, 1. Okay, what does it look like when you just visually look at the figures? What does it look like is happening between the two figures? They're being what? Reflected across which axis? The y-axis. And when we write down our ordered pairs verify that the same points I'm reflecting across y, and I have the opposite value of my x value. So my ordered pairs actually validate my claim that this is a reflection across the y-axis, and these two figures actually are similar. Okay, so again, I'm using transformations as my justification for why these figures are similar. Okay, so I would just say it's reflected, it's a reflection across the y-axis. Reflection across the y-axis. And my ordered pair is proof. Okay, any questions on that? All right, yesterday we touched on proportions. Does anybody remember proportions? I think you had a problem like this. How do I know if the ratios form a proportion? So I had, let's say, 2/3, and I had 14/28. Okay, so I have these two fractions, these two ratios. Do these ratios form a proportion? How do I know? I need to reduce them, right? I need to reduce them. 2/3 is reduced. Okay, is 14/28 reduced?
Yes. No.
No, not even close. 1/2. Okay, you can reduce it by 7, but then it's going to be 2/4. It's 1/2. So no, they don't form a proportion. They don't. But what if there's a part of the proportion that you don't know? What if you had 8/x equals 20/30? 8/x equals 20/30. There's 3 ways to solve for the unknown. You guys remember this from last year? Okay. What do? Cross products. Okay. So cross products tell me that I multiply the terms diagonal from each other. 20 times x and 30 times 8. Go ahead and set up your equation. If you remember how to do it, go ahead and set up your equation, and then we'll show you. All right, so what's 20 times x? 20x. And what's 8 times 30? 240. What am I going to do to both sides now to solve for x? Divide by 20. And what's 20 divided by 240?
120.
No, not quite. Not quite. It is. I heard it. 12. X equals 12. X equals 12. Okay? All right, so we can solve for proportion using cross products. We need this knowledge in order to solve the next problem. Okay? The next problem says that an artist paints a replica image of a painting. Here's the original painting, 15 inches long, 12 inches tall. The replica is 3.7 inches long, 7.5 inches long, and I don't know the height of the replica, okay? So what I need to do is set up a proportion to solve for the unknown side length. All right? Now, if I'm setting up a proportion, here's the number one rule. You must make sure that you're comparing the same value on both sides of the proportion. So whether it's length and length or height and height, or if you're doing one figure compared to the other figure, there's a lot of different ways that you could set this up. All right? The way that I like to teach it is make a ratio out of one of the figures. Okay? And it does not matter if you say 15 over 12 or 12 over 15. It does not matter as long as the other side matches. Okay? It doesn't matter. So let's go 15 over 12. If I say 15 over 12 in my first ratio, which that would be the length over the height, which number from my second figure needs to go in the numerator? 3.75, because it has to match up completely. Because 15 was the length on the big figure, I must put 3.75 in the numerator so they match up. Length and length, and then height and height underneath. All right, so again, we do the cross multiplication, cross products. So we have 15h equals 45. Did everybody else get 45? Okay, divide both sides by 15, and the height of the replica is 3 inches. Okay, so that's just like number 12 on your homework tonight. All right, and I am omitting 9 and 11 from your homework. I'm taking off 9 and 11 from your homework. All right, if that's that is now everything you need to understand for section 2.6. And guys, we're almost done with chapter 2.